Hi, my name is Henry Fernandes, and I'm a product development engineer in the Passive Exchange Group, and today we're going to be talking about cold plates or liquid cooling. So typically for a cold plate, you have either a tube-in plate or a brazed design. So for a tube-in plate, you have some type of copper tubing, typically that is epoxied or soldered into aluminum tray or some sort. For brazed, typically aluminum is used in this option. And you have two halves that are brazed together. So sometimes this can be a lid, where it can be two halves of a cold plate. And this allows for you to machine complex flow path geometries internally and then braze those two pieces together. With a brazed cold plate, it's much easier to have manifolding, which allows for flow separation. This can still be done with tube-in plate, but it would just require additional steps like brazing different copper tubing to each other to be able to manufacture that manifolding. Liquid cooling or cold plates are typically used for high heat flux applications or high power electronics cooling. It allows you to incorporate that into your upper level assembly if you have flowing liquid or flow paths through your system. And typically it is a water or a glycol paste liquid that is used for the cooling application. And these can vary in sizes depending on how many things you need to be cooled or how many cars it will be used. It all depends on the application, but usually isn't limited too much into the size there. The biggest thing with brazed applications are limitations of a braze oven. So sometimes splitting your design into multiple cold plates allows you to actually incorporate this option into your assembly. But that is everything for cold plates and liquid cooling. If you have any additional questions, check the link in the description.